Hello. So this is for your task today and these instructions will be on the assignment, but your job is to either print off the copy of the note sheet that I posted, or it's your job to take notes on some lined sheet of paper, some formal notes on your own if you do not have a printer. But this is going to be kind of going over what we covered a lot last week. But with this trigonometry, right, this measuring of triangles, we're going to get to a point eventually where we're going to measure or use trigonometry. So we're going to use the sine, cosine, and tangent, those trig functions. We're going to use those three functions to find missing pieces of right triangles. So we're either going to use it to find a missing angle or a missing side length. And to start, I just wanted to go through, how do we label triangles, right? If we are given triangle capital A, capital B, capital C, so big ABC, how do we label the sides? Well, we always need to think about corresponding sides, or which ones match with each other. And in this case, you can see that the big A and the little a, those match up with each other. And it just so happens that big A is referring to this angle right here. And this side that corresponds with angle A is the one right across from it. The side that corresponds with angle B is little b right across from it. And the same thing for the right angle C corresponds with the little side length C. And so this is one way that we need to make sure we keep our mindset towards this. A lot of times, and especially with the trig stuff, we're going to be talking about opposite over adjacent, or opposite and hypotenuse. And so opposite, adjacent, and hypotenuse, which you guys reviewed last week. And that is super important, but you're going to get to points where you might have to label the triangles yourself in order to solve some problems. And so just knowing how to label, if always our vertices, the corners of our triangles, or the angles, are always going to be labeled with capital letters. And so you can always say, if the side lengths aren't labeled, you can assign the lowercase letter that's across from the side length. And that is a way that you can label your triangles. Now, moving on to what we talked about last week a bit. And you already watched a video on this, but hey, repetition is what we need right now. I'm not going to move us too fast. So part 2 of these notes is trig functions and right triangles. Pause right now if you need to go back and fill in this diagram. If not, you should be ready to go to move on. So we went through a video, and you guys did a worksheet, and you did a delta on all about, all right, how do I figure out what these ratios are for each of these trig functions? So sine, cosine, and tangent. This little letter here is the Greek. Looks like a 0 with a line through it. And that's exactly how I draw it when I'm writing it out. It's a 0 with a line through it. And what that represents, it's actually a Greek letter theta. But don't worry too much about that. But I'm going to refer to it as theta, or I guess you could say this is kind of like our go-to variable for angles. With a quadratic, or with a linear, or with an exponential, we always use the independent variable x. That's our go-to variable x that we always try to solve for. With angles, it's this little symbol theta. So get used to seeing this little theta around. Now, the sine of theta is opposite over hypotenuse. I'll get to the acronym in a second. The cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite over adjacent. This is all given the theta in this corner. Now, if I were to put theta up in this corner, my opposite would now be in this place where the adjacent is, and the adjacent would be in the place of the opposite. But the hypotenuse always is across from the right angle. That never changes. So pause here if you want to copy this down. Well, okay, not if you want to. You need to copy this down. So pause if you have not done so already. All right, now the last part of this page is our acronym. SOHCAHTOA. It sounds like an Indian chief name. Now, there's other alliterations, there's other little word plays that you can come up with. SOHCAHTOA, you say it how it sounds, right? The phonics of this sounds like SOHCAHTOA. So there you go. Totally fine. But if you want to come up with, if you want to come up with your own little saying for it, you may gladly do that. So, SOH is for our trig function sine, and that is the opposite over hypotenuse, like what I had up here. Ka is with cosine, and that's adjacent divided by hypotenuse. And there we go, adjacent over hypotenuse. And then for toa, tangent, opposite over adjacent. Trust me, guys, this is something you will never forget. SOHCAHTOA. It's for whatever reason, it just sticks. These acronyms stick. And so when I say it's a handy acronym, it really is. It's something that I can guarantee you for the rest of your life, you will always remember. I remember when I was in high school, I would ask my mom for help because she's a math minor, and she taught middle school math for a little bit. And when I got to this point in Core 2, SOHCAHTOA, she knew exactly what I meant when I said SOHCAHTOA. That is a universally known thing, because here in the U.S. we like to make things procedures and algorithms and patterns rather than thinking about the concepts themselves. But in this case, this acronym is extremely beneficial to remembering what the sine ratio is. Well, it's opposite over hypotenuse. Now, I'm saying the sine of theta equals opposite over hypotenuse, like what we have over here. And you're wondering, okay, great, but what's the benefit to that? Where is that going to take me? Where am I going? And that's what we'll cover tomorrow in the notes. Or not necessarily tomorrow, potentially Wednesday. So the handy acronym, SOHCAHTOA. The last one is tangent, which is your opposite over adjacent. Go ahead and pause the video right now to make sure you have this copied down in your notes. And we're going to move on to the last piece for today's lesson. Often, as I described above, we'll get a triangle ABC with little a, little b, little c. And we're not going to label our triangles with the sides opposite, adjacent, hypotenuse. They're going to be labeled like this: big A, big B, big C, with little a, little b, little c as the side lengths. And so I have a little table here that kind of gives us, all right, how do I deal with this? So SOHCAHTOA, how do I make the connection between opposite over adjacent and hypotenuse with what my triangle actually has? And so in this case with ABC, if I were to take the sine of angle A, what's the side length that is opposite of A? Well, that's little a. What's the side length that is the hypotenuse? That's C, because it's across from the right angle. So sine of A is A over C. Well, what if I actually went up to angle B? Well, the sine of angle B is opposite over hypotenuse. Well, what's opposite of big B? Little b. So it's going to be little b divided by the hypotenuse, which is C. Moving on to cosine. Cosine of theta equals blank. Well, when theta is A, when this is our angle we choose, well, cosine of A is adjacent divided by hypotenuse. Well, A is opposite, and so that must mean that B is my adjacent because C is my hypotenuse. So the cosine of A is going to be B divided by C, because B is my adjacent side, C is my hypotenuse. What if we switch it up and we do the cosine of B? Well, no longer is little b the adjacent side. That's the opposite side now. So it switches over. Now my adjacent side is little a. So cosine is adjacent divided by hypotenuse. So adjacent A divided by hypotenuse C. Finally, we've got the tangent of theta. Tangent of A, right, moving at A again. Tangent is going to be opposite over adjacent, toa, right, SOHCAHTOA. So opposite over adjacent, so A over B. A is opposite, B is adjacent. The tangent of B, if I switch my angle to be over here, so theta is over here, opposite over adjacent. So katoa. Opposite is B, adjacent is A. So B over A. Now, this is just our lesson for today. I need you to make sure that you have watched this video in full, and I need to make sure that you have completed your notes. And so what you will do now at this point is you will be sending me your note sheets that you have sent back or that you have completed. You will re-upload those, take pictures of them, and submit them onto Moodle so that I can see that you have done today's assignment. It's a small one, but it's important that you have it done along with all your other assignments. So don't let missings pile up. We've got a week until Thanksgiving, or not Thanksgiving. Wow, Dealman, what did you just do right there? You got a week until spring break. And then it sounds like we'll be doing school for sure till the 13th online. That's right after spring break. And then we'll see what the governor says from there. But anyways, step 1, here we are. Step 2 will be your assignment tomorrow, and we will go from there. All right, see you guys. Thanks for tuning in.